Hello students, welcome to an academy. This is your KP sir, Krishna Prakash. So today our session is related to UPPSC, AE, AEE, Hydrology. This may be helpful for any kind of any category of examination.
Interesting देखोगे तो interesting सोचोगे. Discovery plus app.
So this may be helpful for any kind of AE, AEE examination, not only UPPSC. For any state government AE, AEE examination, this is going to helpful. Before going to start the session, I have a small announcement. From 29th September onwards, in Unacademy Plus subscription, I am going to start a new batch of environmental engineering. And the same geotechnical engineering started by Abdul Rafi sir. So the new batch of environmental engineering and geotechnical engineering is going to be started from 29th onwards. So take your Plus subscription as early as possible. Along with your Plus subscription, if you use my code KP Civil or InjiGuru, I am going to provide you additionally free study material, free online test series. So it is a live interactive classes for full-length course of GATE and ESC. Remember, if you miss the class, you can go for recorded, no problem. If you does not miss the class, live interactive session, directly faculty will interact with you. So you are getting 6 months subscription for 18,000 rupees, 1 year subscription with 22,500 rupees. So new batch is going to start from 28th September. Join as early as possible. Okay. Good evening, Rahul. So we are going to start. Already we completed 8 sessions on hydrology for AEA. Today 9th session related to hydrology. Today's topic is Evapo transpiration. Evapo transpiration. What is Evapo transpiration? For example, consider. So this is ground level. The plants have been present here. This is plant material available. So several plants cultivated one after another. Several plants cultivated available one after another in the soil. You have given water into soil through surface irrigation, subsurface irrigation, whatever the method of irrigation may be. Through various methods of irrigation, water is provided. So that water is absorbed by plant, and after absorption the plant is releasing water into atmosphere. The absorbed water released from plants into atmosphere. That the phenomena of release of absorbed water by the plants through plant leaf surfaces. Through plant leaf surfaces. That phenomena, what we call that phenomena? That the phenomena will consider it as a transpiration. Then already this soil is wet soil. So this is a wet soil now because water is given to soil. As water is given to soil, the soil is said to be wet soil in condition. Then into wet soil. Will soil permanently wet in condition? Water is absorbed by soil, given to plants, still it is wet. Will it be permanently wet in condition? Whenever sunlight appears, some amount of water is going to be undergone evaporation. Some amount of water from the surrounding soil surfaces. Some amount of water from surrounding soil surfaces escape into atmosphere. You understand? Some quantity of water from surrounding wet soil escape into atmosphere. So combinedly, this transpired water as well as evaporated water from wet soil. Combinedly, this transpired water and evaporated water from wet soil gone and disposed into atmosphere. That disposal of water evaporated from wet soil strata and transpired water from plants. That combined phenomena is called as evapotranspiration. Here, water from the plant leaf surfaces releases into atmosphere, transpiration. Water from wet surfaces of soil travel into atmosphere, evaporation. Both combinedly, they diffuses and accumulated in the atmosphere. Both combinedly we call it as evapotranspiration. We'll write down the definition here. The phenomenon of diffuse of water, the phenomenon of diffuse of water as a vapor, diffuse of water as vapor into atmosphere. The phenomenon of diffuse of water into vapor, water as vapor into atmosphere. From where? From wet surfaces of soil, surrounding the plants. Very good, Rahul. And also from leaf surfaces of plant. Is called as evapotranspiration. Is called as evapotranspiration. Clear? From two sources. One is wet soil surfaces, second one is plant leaf surfaces. Combinedly diffusion into atmosphere. That is called evapotranspiration. Now, measurement. So before going to measurement, we have the three terms related to evapotranspiration. First one PEP. Potential evapotranspiration. So potential evapotranspiration. What is meaning of potential evapotranspiration? The evapotranspiration occurred when soil moisture capacity is at field capacity. When soil moisture capacity is at field capacity and the maximum rate of evapotranspiration. Maximum rate of evapotranspiration happened is called as potential evapotranspiration. Soil moisture capacity is at the field capacity. What is the meaning of that? All voids are completely filled with water. Porous spaces 100% occupied by water. Full water. Soil is having sufficiently flooded water. In such a case, absorption of water by the plant, transpiration from the plant, and also evaporation from wet soil surface also high. So, as the soil is sufficiently carrying moisture capacity, you understand? As the soil is sufficiently carrying moisture capacity, transpiration is high, evaporation from soil surfaces is high, so that maximum evapotranspiration takes place. As the soil moisture capacity is maximum, that maximum evapotranspiration is called potential evapotranspiration. That maximum evapotranspiration is called potential evapotranspiration, PET. Clear? Is it clear? Done. We'll have another word, one more word. AET. Soil moisture capacity less than field capacity. Only some amount of pore spaces are filled. Then in such a case, less availability of water. The actually available amount of water is absorbed, and that is only undergone evaporation in the transpiration. Actual evapotranspiration. Actual evapotranspiration. Evapotranspiration occurred at a specific time. Evapotranspiration occurred at a specific time for a specific soil. For a specific soil, depending upon its moisture capacity. Depending upon its moisture capacity. That is said to be actual evapotranspiration. For a particular time, for a particular soil, and the soil moisture capacity is not at field capacity, is less than field capacity. So actually, originally, how much amount of water is getting evaporated and transpirated. So that the practical evapotranspiration is called AET, actual evapotranspiration. We have one more word here, CU. CU is called consumptive use. CU, consumptive use. We will discuss this CU, consumptive use, in detailed in irrigation. In irrigation, as of now, yes, correct, Rahul. Soil moisture capacity is between FC and PWP only. In such a case only the evapotranspiration occurred is AET, no doubt. Soil moisture capacity is between FC and PWP only. In such a case only we are going to have that actual evapotranspiration. So consumptive use is equal to potential evapotranspiration plus water stored inside the plant body participating in metabolic activities of plant body, and that water, what it is doing? Involved in metabolic activity, plant life activities, participating in plant life activity, metabolic activities. That water is called consumptive use. Means we are not at all leaving very small amount of water. Potential evapotranspiration plus some amount of water which is stored inside the plant body which is involved in participating metabolic activities. That water stored in the plant body plus PET, that is Cu consumptive use. Then we'll go ahead now. If here we have three cases. If potential evapotranspiration is equal to actual evapotranspiration, both are same, means we'll consider AET by PET, actual evapotranspiration by potential evapotranspiration, is equal to 1. AET by PET, actual evapotranspiration by potential evapotranspiration, is equal to 1. Then what is the soil moisture capacity? Soil moisture capacity is at field capacity. AET by PET is equal to 1. Then we'll conclude soil moisture capacity is at field capacity. Second case, AET by PET less than 1. AET by PET, actual evapotranspiration by potential evapotranspiration, less than 1. Hello Krishna, good evening. Now in this case, AET happened, actual evapotranspiration happened is less than potential evapotranspiration. Actual evapotranspiration happened is less than potential evapotranspiration. What is occurring? Soil moisture capacity is between FC and PWP, field capacity and permanent wilting point. Soil moisture capacity is between FC, field capacity, and permanent wilting point. Third case we'll consider. AET by PET is equal to 0. AET by PET is equal to 0. Then what is the condition? Soil moisture capacity is at PWP. Plants are not getting any water. Soil is not wet. Water content, moisture content in the soil is at a permanent wilting point. That is relation between AET and PET. Here, that is the relationship between AET and PET. Here we'll consider very important for your AE, A-double examinations. Very important for your AE, A-double examination. Aridity index, most important formula, repeated formula. PET minus AET by PET into 100. Potential evapotranspiration minus actual evapotranspiration by potential evapotranspiration into 100. Aridity index, potential evapotranspiration minus actual evapotranspiration by potential evapotranspiration into 100. What the aridity index will represent? Aridity index AI, it is representative of agricultural drought. Factor representing, aridity index is the factor representing agricultural drought in a region, in a location. So most important, remember this theoretical question. We are expecting this question from AE double exams. The factor representing agricultural drought is, what is the factor representing agricultural drought? Aridity index, AI. PET minus AET by PET into 100. If aridity index is less than 25%, aridity index is less than 25%, the drought is a mild drought, less than 25% mild drought. Aridity index is between 25 to 50%. The drought condition we call it as a moderate drought. Aridity index between 25 to 50%. The drought condition will consider it as a moderate drought condition, less than 25% mild drought, greater than 50% severe drought. Greater than 50%, it is said to be severe drought condition. These are the conditions of aridity index. So very important, the formula and the second point representing agricultural drought. PET by AET, PET minus AET by PET into 100, and it is representing agricultural drought. That is very, very important. Okay. Estimation of evapotranspiration. Estimation of evapotranspiration. Instrument used to measure. Just remember the name of instrument. Actually, it is not an instrument. It is a plant. It is a plant. But we name it with the word instrument. Lysimeter. Lysimeter. The instrument used to measure, estimate evapotranspiration. Instrument used to measure or estimate evapotranspiration, that is lysimeter. Lysimeter. So according to this formula, evapotranspiration is equal to correct Surya. According to this formula, instrument evapotranspiration is equal to final weight of the plant after observation period minus initial weight of the plant before starting of experiment plus change in moisture content of the plant. Soil. Just in a pot with adequate drainage area, a plant is inoculated. Water is provided throughout observation period. You may take your observation period 7 days, 10 days or 1 month. Before starting the experiment, initial weight of pot, soil and plant, that is the W1, initial weight. Continuously every day you are giving water into the plant. Then final weight after 1 month is measured, that is W2. The first and last day, moisture capacity of soil is different. That change in moisture capacity, that is estimated delta MC. And the second equation, second method, an empirical equation, we call it as a Penman's equation. Second equation, we'll consider it as a empirical equation. Penman's equation. Empirical equation, Penman's equation, which is obtained from a combination of mass transfer. Very good, Rahul Gautam. Mass transfer and energy balance method. Mass transfer and energy balance methods. The sound is the problem to everyone. Penman's equation is from mass transfer and energy balance method. Combination of mass transfer and energy balance method. So we can write down evapotranspiration EP is equal to delta HN plus E into gamma divided by A plus gamma. This is Penman's empirical equation related to evapotranspiration. Don't worry, mostly equation is not going to be asked for your exam. Just you remember the word, it is a combination of mass transfer and energy balance method. Clear? Mostly equation is not required. Just you remember this as a mass transfer and energy balance method combination. So what is the delta HN? Net radiation participated in the process. Net radiation participated in evapotranspiration, that is delta HN, net radiation. A is slope of saturated vapor pressure and temperature curve. Slope of saturated vapor pressure and temperature curve. A. Gamma, psychometric constant. E. Again, it is a constant related to wind velocity and pressure. Constant related to wind velocity and pressure. So delta HN is net radiation. A slope of PS, saturated vapor pressure and temperature curve. Gamma, psychometric constant. E, constant related to wind velocity and pressure. So just now we have seen one question now. So this is a question given in UPPSC. This is the question given in UPPSC previously. The Penman's evapotranspiration equation is based on. Tell me, Rahul, what is the answer? We discussed just now, we have written the Penman's evapotranspiration equation is based on energy balance and mass transfer method. Energy balance and mass transfer method. Any doubt? Just now we have written about it. Energy balance and mass transfer method. No. The third one, most important, the most common method what we are using. Most common method what we are using. Blaney-Criddle equation. Blaney-Criddle equation. So according to Blaney-Criddle equation, we'll consider either consumptive use or potential evapotranspiration. Both will be considered approximately same. So PET or Cu is equal to K into EP. K into EP. Blaney-Criddle equation or potential, Blaney-Criddle equation for potential evapotranspiration or consumptive use, that is K into EP. K is a crop factor, plant to plant, which is varying. that crop factor albedo, we call it as albedo. K is a crop factor or albedo which is varying from plant to plant. EP, what is EP? Nearby pond evaporation. So pond evaporation. So instead of taking pond evaporation, we are considering another formula provided by Blaney-Criddle, PTM by 100. PTM by 100. So substituting for EP, PTM by 100. Now what is the CU or PET? Consumptive use or potential evapotranspiration. Now how can we write down? KP TM by 100. KP TM by 100. Consumptive use or potential evapotranspiration. Substituted, you get the value. Consumptive use or potential evapotranspiration, Kp Tm by 100. So K already given, P, this P, percentage of mean monthly sunshine hours. Percentage of mean monthly sunshine hours. On a month, on an average, daily some number of hours are going to occur. Their percentage of mean monthly sunshine hours is taken as a P value. Tm. What is Tm? Mean monthly temperature. Mean monthly temperature considered in degrees Fahrenheit. Considered in degrees Fahrenheit. So temperature in degrees Fahrenheit, percentage of mean monthly sunshine hours in percentage we have taken. So potential evapotranspiration is equal to Kp Tm by 100. Which units we are getting? We are getting this in terms of inches per month. Inches per month. So to convert it to mm per day, clear? To convert it to mm per day, then you take Kp Tm by 100 into 25.4 by 30. 25.4 by 30. So inches per month is converted to mm per day. This is potential evapotranspiration. Potential evapotranspiration in mm per day with respect to Kp Tm by 100 into 25.4 by 30. Because 1 inch is equal to 25.4 millimeter. 1 inch is equal to 25.4 millimeter. 1 month we are considering, that is 30 days. So 25.4 by 30 inch per month to mm per day conversion, Kp Tm by 100. Clear? Clear, we'll go ahead. So now we are entering into the most important topic for any competitive examination, infiltration. Infiltration. So every day several liters of water we are extracting from soil. We are taking by the wells, bores, motors, pumps, we are extracting water from the ground level. From the zone of saturation, from groundwater table. Every day we are extracting water. Are you providing water any even single liter to ground level? If your mobile balance is over, you are making recharge. You are making recharge and you are using the balance. Whenever balance is completed, again you are doing recharge. For your mobile you are doing recharge. You are not doing recharge to soil. Are you doing recharge? Are you providing even 1 liter of water, throwing some 1 liter of water into soil? Never human can do. So nature identified, knows the selfish behavior of a human. So nature itself created its own recharge of groundwater table. That nature's creation of own recharge of groundwater table, zone of saturation, that is called infiltration. You understand? Nature has created its own replenishment or recharge of groundwater through some natural phenomena. That natural phenomena we call it as infiltration. That natural phenomena will consider it as infiltration. So write down the definition. The phenomena by which replenishment or recharge of groundwater occurs Palmer index, aridity index, approximately same we can say, but not 100% accurately. Values, measuring parameters are same, Rahul, but they won't give exactly same value, but they are representing drought only. Both the Palmer index as well as aridity index, both are representing drought only. The phenomena by which replenishment or recharge of groundwater through vertically downward movement of water, vertically downward movement of water in subsoil, that is capillary spaces, during rainfall. During rainfall is called as infiltration. So infiltration is the phenomena which is going to occur during rainfall. Here, infiltration is the phenomena which is going to take place during rainfall. The water passage vertically downward direction in the zone of aeration followed by zone of saturation finally causes a recharge of groundwater. That phenomena by which replenishment of groundwater takes place. Recharge or replenishment of groundwater takes place. That is called infiltration. For example, this is the ground level. This is the ground level. From atmosphere, rainfall occurred. From atmosphere, from the clouds, rainwater droplets are falling down. Rainfall occurs. Now the water is going into a catchment, but there is no availability of catchment here. So due to non-availability of catchment, water will overflow on the surface. That overflowing water exerted That overflown water exerted some pressure, then water travels into topsoil, the topmost surface of soil, then after that it enters into subsoil, which include zone of aeration, zone of saturation, intermediary vadose zone. Then water reaches to water table. Then water reaches to water table. This is water table. So through the soil pores, water passes downward direction vertically. Through the soil pores, water passes downward direction vertically, and then finally enters, reaches to water table. That phenomena, that phenomena of recharge of groundwater, that is called as infiltration. Infiltration. Clear? Here again, with respect to infiltration, like how we are having the words PET, AET with respect to evapotranspiration, same here again with respect to infiltration, we have the words. First one, FC, saturated infiltration capacity. Sabin Salahuddin, this is only AE, AEE class. Only I will include AE, AEE previous questions. Already I have done a video on gate PYQs also. And also year-wise gate solutions I will release next month. Sabin Salahuddin, this month I am releasing environmental engineering gate PYQ videos. Next month I will release hydrology gate PYQ videos. So that is a separate videos. In separate videos I will stream all subjects individual year wise. 2020 environmental engineering, 2019 environmental engineering, like that. Each year wise I will solve the questions and I will release the video. That will be streamed in YouTube. Okay, gate is a separate. This is exactly related to AEW only. Saturated infiltration capacity of soil. Saturated infiltration capacity of soil. So that is nothing but the maximum possible absorption. Maximum infiltration capacity rate, FC. Maximum infiltration capacity rate, FC. Whatever the water you are providing, whatever atmospheric conditions, the highest amount of water absorbed by soil, that total highest possibility, maximum possibility to absorb the water, that is said to be highest possible absorption, that is said to be FC, saturated infiltration capacity of soil. Then, so soil is capable of taking 5 mm per hour, but rainfall is occurred 1 mm per hour. Will it absorb? Clear. Soil saturation capacity is 5 mm per hour. Source is providing, rainfall is providing 1 mm per hour. 1 mm per hour. Will it absorb 5 mm per hour? Will it take 5 mm per hour? Rahul, tell me. Soil is capable of taking every hour 5 mm depth, but rainfall occurred is providing every hour 1 mm depth. So how much it will take? Rahul is capable of eating 5 apples, but available apples are only 1. Then how many he can eat? Rahul capacity to eat is 5 apples. Availability is only 1 apple. Then how many he can eat? He can eat only 1. Only 1 he can eat. Same manner, soil is capable of taking 5 mm per hour. But availability is 1 only. Source is providing only 1. It will take full 1 mm per hour. It will take full 1 mm per hour. So that is called, depending upon intensity of rainfall, actual infiltration rate based on availability of rainfall intensity. Source, actual infiltration rate. This actual infiltration rate is based on intensity of rainfall. Based on intensity of rainfall, whatever actually passed towards subsoil strata, zone of saturation. That is called actually, practically occurring information. Practically occurring, that is FA. Maximum capable of taking, that is FC. So here we are having two cases. Case 1 and case 2. We are having two cases here. Case 1. Intensity of rainfall occurred is greater than soil's full capacity, soil's maximum capacity. Rainfall occurred, intensity of rainfall, I will give with example. Intensity is 9 mm per hour. Soil capacity FC is 5 mm per hour. So now what is FA? How much soil is absorbing? Intensity is 9 mm per hour. Rainfall, I means intensity of rainfall. Intensity of rainfall is 9 mm per hour. Soil maximum absorption capacity is 5 mm per hour. So depending upon rainfall, I is greater than FC. What is actually capable of absorbing? How much it can take soil? Soil will take 5 or 9. Rahul capability to eat is 5 apples. 20 apples are there. How much Rahul can eat? Will he eat all 20? 5 only na? 5 only na? So same. FA 5 mm per hour. Actual capability, that is 5 mm per hour. So answer is 5. So what is FA now? Intensity of rainfall greater than saturation capacity. FA is equal to FC. Intensity of rainfall greater than saturation capacity. Intensity of rainfall greater than saturation capacity. FA is equal to FC. Case 2, second condition. Intensity of rainfall less than FC. Intensity of rainfall less than FC. Then we'll take example. Intensity of rainfall is 2 mm per hour. FC is 5 mm per hour. Soil is capable of absorbing 5 mm. Source is providing only 2 mm. How much soil can absorb? Soil is capable of absorbing 5 mm. Source is taking 2 mm only. Source is giving 2 mm only. How much soil can absorb? How much soil can absorb? Tell me. FA is equal to 2 mm. Very good, Rahul. 2 mm per hour. FA is equal to 2 mm per hour. So now what is FA here? FA is equal to FC. FA is equal to FC. Clear? Intensity of rainfall is less than saturation capacity, then actual infiltration capacity is equal to FA is equal to I. FA is equal to I. FA is equal to I. Remember I. Intensity of rainfall. So actual infiltration is depending upon either intensity of rainfall is greater or less than the capacity. FA is equal to I. Okay. We have one more word here, one more letter. FT. FT. Rate of infiltration at a Tth hour. For example, rainfall occurred for 6 hours. So whatever infiltration happened at 4th hour, only exactly for 4th hour, starting of 4th hour to ending of 4th hour, exactly happened from starting to ending of 4th hour, that is F4. That is F4. That F4 is taken as FT, infiltration rate at a Tth hour, F4. Here exactly for a specific hour, exactly for a specific time duration, that is infiltration rate at a Tth hour, FT. Clear? Now measurement of infiltration. Measurement of infiltration. This is infiltrometer. Infiltrometer. The first instrument we are talking. First method or instrument we are talking, infiltrometer. This is called a single ring infiltrometer. The diagram is related to single ring infiltrometer. So that is visible to you clearly. So below ground level, a circular ring is placed without disturbing the soil strata. Here, without disturbing the soil strata, below ground level, a ring, a hollow metal ring is incorporated. Below ground level, this is ground level, a hollow metal ring is immersed, placed without disturbing the soil strata. Then, day 0 to day 10. For example, your observation period is 10 days. For example, your observation period is 10 days, day 0 to day 10. Every day you are loading some quantity of water. Load volume of water into infiltration ring. Load up to stipulated head, constant headline, given a constant headline. Up to constant headline water is loaded. Whenever water fall down below water level declared constant headline, immediately add water. Like that, continuously you add water into infiltration ring. The last day of observation. Clear? Last day of observation period. You are not measuring using the scale. Here that is just for example they have placed there. We are not at all considering scale measurement. Depth of infiltration. Every day you are measuring volume now. Every day how much volume of water you are loading. You only loading now. Who is loading there? The previous picture. Who is loading? Human beings only loading now. Every day we are loading water into it. So that volume, day 1 volume, day 2 volume, day 3 volume, like that, we have measured that measured volumes daily. Every day measured volumes we have taken. So sum total volume of water loaded. Total volume of water loaded divided by area of infiltrometer ring, area of ring or area of infiltrometer, that gives you depth of infiltration. So you are measuring using that formula only. Remember, you are not at all measuring using the scale. So total volume of water loaded into infiltrometer for the entire observation period. Total volume of water loaded into infiltrometer for the starting day 0 to last day divided by area of ring, area of infiltrometer. But the disadvantage here, you are loading water into it. When the water is saturated horizontally, you are restricting water to go into vertical downward direction only. There is no horizontal saturation of water because the ring is restricting. So there is no horizontal saturation. This was not happened. It is not at all similar to rainfall. Because of that reason, they come with another proposal. That is double ring infiltrometer. Double ring infiltrometer. A ring inside other ring. Internal ring and external ring. Two rings are provided. Internal ring and external ring. Two rings are provided. A double ring infiltrometer. So when you have provided this double ring infiltrometer, water is loaded, volume of water is loaded into inner ring. Inner ring of 30 centimeter diameter, external outer ring of 60 centimeter diameter. But where water is loaded? Water is loaded into internal ring. But entered water, what happened to entered water? The entered water is going to transmit horizontally because pores are there. Through the pores it is a transmitting horizontally, it is a transmitting towards external ring. And also after entering into soil, again it is transmitting into soil. So both the horizontal and the vertical flow, lateral flow is there, clear, lateral flow is there, vertical transmission is also there. So it is somewhat similar to our rainfall activity. So again you use same formula. Again you use same formula, no change. Formula is no change. Depth of infiltration. There is no change in the formula regarding depth of infiltration. Same. Total volume of water loaded into ring. Total volume of water loaded into ring divided by area of internal ring. Because where you are loading the water? You are loading water into inner ring only and not into external ring. So area of inner ring, internal ring, depth of infiltration. So observation period day 0 to day t, 0 to t days, total water loaded into internal ring divided by area of ring, that is a double ring infiltrometer. Clear? So remaining concepts will continue tomorrow, same time 5 p.m. no change. Tomorrow will continue Most important we'll discuss tomorrow Horton's infiltration equation and also index value, phi index, W index. Very, very important. Don't miss the session tomorrow. Tomorrow same time 5. Okay. So important announcement. Trust the best for your GATE and ESC preparation. If you are not preparing for GATE and ESC, your friends are preparing, your juniors are preparing. Refer your friends and juniors to an academy, because in the market so many coaching centers are selling recorded classes as online. Online means live interactive classes. You remember this. Online means live interactive classes. An academy only providing live interactive classes in India with very best price. Clear? An academy only providing live interactive classes with the best price. 6 months 18,000 rupees, 1 year 22,500 rupees, which is starting a new batch. That new batch is going to launch from 29th September. Including within this fees, you will get free study material, free online test series. Remember that point. Within the same fees only, you are getting free study material and free online test series. So you can watch the video not for 1 time, 2 time, 3 time. Restrictions will be there in other coaching center. Here no restriction. Watch for unlimited times. How many times you can watch it. Okay. So we'll meet tomorrow again. We are having the best topmost faculty in India. RPs are who is the legend of structural subjects. Myself, I will teach environmental, hydrology, irrigation, open channel flow. Abdul Rafi sir, he will teach geotechnical engineering. So we three will cover all the subjects required for core civil engineering. So that take your plus subscription, use my core KP Civil. Use my core KP Civil or Engineering Guru to get all the benefits. 10% discount, free scanned copies of materials and notes, free online test series. Okay. Thank you one and all. Bye bye all of you.